Okay, here's part 4. We're getting ready to mount the solar roof up. So what I did was I got two pieces of 6-foot aluminum 1/8-inch angle iron, and I made a 45-degree cut down in this corner and a 45-degree cut in this corner, and then bent them together and then joined them using a piece of straight aluminum right here with 4 screws. Then I covered it with plexiglass. That plexiglass will kind of fill in the low spots to keep the panels supported. So I used a nut insert to insert this nut into the top here. There's the top nut insert. There's the rivet tool that inserts the nut. So I got these rails that they're screwed to the top, and the next design will be screwed to the side, but they screw down. I got slots cut in the outside of the solar panel. It'll let the solar panel grow and shrink. But basically we just put them in and screw them down, and then they retain the solar panel instead of using the grommets that they gave us, because there was a lot of movement in this panel, and now it'll have the ability to expand and contract. To let you know what it looks like on the other side, here's the rail that's not hooked up yet, and then there's a for it, and then it'll come down and bolt on there, and it'll retain it. So this is what it looks like when all the rails are done, and I haven't decided, like, I'm thinking about getting some HDP, so high density polyethylene plastic, and putting it up here as a kind of guard, even though it is very low profile. I got some went to the flooring store, found some threshold that matched to kind of guard the front of the solar panel. So I got that getting glued down. You can see the threshold, the plexiglass, and then the stock top. I mean, it's a line, and it doesn't look the greatest right now, but I'll do something better in the future. But or I might, if it rides like that, I might just leave it. Who knows? As long as it looks fine and lasts a long time, right? Anyway, that's the solar top. The next thing we got to do is get the charge controller on. I'm planning on mounting that underneath here. Here's the cords for it. I'm going to take these 2 bolts off, lift the top up, snake this wire here. I'm going to snake that down into the battery compartment area. I'm going to cut off these and stick ring stay-cons on it so we can plug the solar charger in, and it'll be done. So just like that, she's done. So here's a solar charge controller. It's mounted in this box. I drilled 2 holes, put a piece of mesh screen in there to keep bugs out, and we can see that it's showing 53.2 volts at 1.5 amps. We're going to check that in a little bit to make sure that that thing's accurate. And we're going to compare it to this cart. They're both sitting in the same spot in the same sun. You'll see the installation looks pretty clean. Here's the 2 wires coming down. They're tucked up underneath here, plugged into the solar charge controller. On the other side, we have the battery wires. They're tucked along there, and they go up that strut, into the strut, down the strut. They come out of the strut down here, and go into this piece, that trim piece, and then end up coming out into the battery area where they're connected with a plug. Now, for whatever reason, because this this came reverse polarity because the positive pin is always supposed to be protected. I had to switch the black going to the positive and the red going to the negative because it had an exposed pin over here on the positive side, on the red side. So I did have to switch the polarity on that. I just bought this from, this is a Harbor Freight solar panel connection kit. So that's where I got all the wire from. It cost me $9.99. So that's it for the solar panel. It's hooked up. The charge control, the onboard charger, they just took a piece of sheet metal and painted it black, screwed it into the stock ports, and then zip screwed this thing to it. So all you need to do is plug in any extension cord to this. It'll charge on 120 volt. Here's the dash. Again, another piece of sheet metal that's just screwed over that recess. So the dash is in. It's showing it's charging at 90%, and it's showing 1.5 amps of current. So the voltage is 53 at 1 point. So you multiply the current times the voltage, and that'll give you the wattage. So it's like, right now I'm getting 75 watts out of it approximately. Over if it gets 75 watts over an hour, it'll be 75 watt hours. So anyway, so when I ran the cord for that, got to take out one, 2, 3, 4, 5 Torx head screws, and then this snap-in connector right here. And you can peel this rug up. There's a wire tray harness that goes up, comes up here underneath the dash. It was real easy to do. The hardest thing to do here was hooking the doing the structure for the solar top, because you know, you can't have this thing flopping around in the breeze. This is just transition for flooring that I put up here to keep the wind from getting underneath the solar top. You can see the solar top tucks up in there, so it retains the front of the solar top as well. So when you're towing it on down the highway on a trailer or something like that, you don't want to have wind get up underneath of this thing. So step away from it to show you how low profile that top is. It's not gonna like get snagged up by too much. If I could change a couple of things, one thing is I would change this thing so it came off the bottom of the panel instead of the top. I got another panel. I might see how much work that is to get that done. And instead of using a plexiglass and an 1/8 inch 3 by 3/4 angle for the structure, I would just go with a piece of 1/8 inch aluminum, pan the whole thing out, break a couple of 90s down for the sides and the back. And then the other thing I would change is these two sides. Instead of 1/2 by 1/2, I would go 1/2 by 3/4, so I could screw them into the side. So if you ever need to maintain the panel, you could just undo the back plate and slide the whole panel out, slide a new panel in. I have a suspicion that even though this panel is rated at 300 watts, we're going to compare it using this fluke meter. Both of these carts are sitting in the sun. It's like 9 a.m. right now, and I just want to see what kind of charge we're getting. Hole 1 at the Dream, 96%. Oh, well, I forgot. The turn's up there. We're on the 10th hole. We're at 91% charge. 10th hole of the Dream. So we lost 5%. As you can see, I'm sitting in the shade. I'm not trying to do anything special, like drive it any differently than I can. Anyway, that's it. Okay, we just finished up 18 holes of the Dream. Battery is now at 85%. We started the golf course out at 96%, but we started the day out with 90% in the battery. So it hasn't been on the charger. It's only been solar charged. So basically, it cost us 5% of power to golf 18 holes for today. The rest was restored by the sun. Not exactly what I was hoping for, but better than nothing. Here we are, hole 1 of the Loon. Beta test 2. We're starting out with 91% battery. The Loon. So here we are at the Loon, hole 11. We're at 87 or 84% battery now. It's been overcast almost all day. We finally got some full sun, but like I'm only showing 1.7 amps going in, and every amp is 50 watts. So like I'm getting like less than 100 watts out of this solar panel right now, and I'm kind of disappointed with that because it says it's a 300 watt solar panel. I'm feeling like this amount of sunshine should probably have me at least at like 150 or 175 watts, if not 200. So there might be something wrong with the solar panel, don't know.